We ask self-driving cars to do something that's, well, basically impossible. We want them to make superhuman predictions about the future, but they have to do it on a computer that could probably fit in a shoebox. So they need this brain of a supercomputer, but they can't exactly carry one around in the trunk. It's a paradox, right? Well, a new technique might have just cracked the code.
So today, we're going to break down this incredible breakthrough. We'll kick things off with the core challenge, what we're calling the prediction problem. Then we'll see how researchers built an AI dream team. From there, we'll get into the really elegant solution, the teacher and the student. And of course, we'll look at the data to see the proof. And finally, we'll explore what this means for AI way beyond just cars.
All right, so let's start with the fundamental challenge for any kind of autonomous system. It's all about trying to predict the unpredictable, and by that, I mean us, humans. What are we going to do next?
Really think about it for a second. Every single second, on every street, a self-driving car is playing this incredibly high-stakes prediction game. Is that cyclist over there going to turn? Is that person on the sidewalk going to suddenly step off the curb? Getting it right isn't just about being efficient. It's about keeping everyone safe. This image, wow, it just reveals the sheer, mind-boggling complexity of the problem. A self-driving car isn't just making one little prediction. Oh no, it has to forecast this whole web of possible futures for every single car, every cyclist, and every pedestrian around it. And it has to do it all at once. It is a massive computational puzzle that has to be solved in milliseconds.
And that right there brings us to the core constraint. The computer inside the car only has a finite amount of processing power. Engineers call this a compute budget. And this forces a really painful trade-off. You can either have a super accurate AI that's way too slow to react in time, or you can have a super fast AI that just isn't smart enough to be safe. You can't have both. Or can you?
So to get around that trade-off, researchers started by thinking, okay, how do we make the AI smarter? Their first big idea? Instead of relying on just one AI brain, they decided to build a whole team of them.
This is a classic idea in AI, and it's called a model ensemble. The concept is simple. Instead of training one AI, you train a whole bunch of them, all independently. Then, when it's time to make a decision, you have them all vote on the most likely outcome. It's just like a council of experts. Their collective wisdom is almost always going to be better than any single expert's opinion.
And this slide just perfectly illustrates the difference. The top image shows a single AI's prediction, and it's pretty decent, but it might miss some key possibilities. But now look at the bottom image. That's the ensemble. Its predictions are richer, they're more diverse, and they're much, much closer to what could actually happen on the road. It's just smarter.
Okay, but this brings us to a major roadblock. A single model is fast enough to run in the car, but it's just not accurate enough. The ensemble model, on the other hand, gives us that superhuman accuracy we desperately need, but it's way too big and way too slow to run on the computer inside a vehicle. So we have the perfect brain, but it's stuck in the lab.
And hey, don't just take my word for it. The researchers who actually developed this technique say it themselves. The best solution they have, the ensemble, is basically unusable in the real world. So we've hit a wall. And this is the exact kind of problem that needed a genuinely new idea to solve it.
And that new idea? It is both incredibly clever and beautifully simple. It's a method called knowledge distillation. And honestly, the best way to think about it is with a teacher and a student.
So here's the concept. You have your massive, brilliant, but super slow teacher model. That's our ensemble. It's too big to go in the car. But you also have a small, fast, efficient student model. The goal is to somehow transfer all the wisdom, the intuition, and the deep knowledge from that big teacher into the small student.
So check out how this process actually works. The big teacher ensemble does all its heavy lifting offline in a massive data center somewhere. It just chews through millions of scenarios and generates this set of perfect, nuanced predictions. Then, all of that refined wisdom is distilled down and becomes the only textbook the smaller student model ever studies from.
So let's just break it down into 3 simple steps. Step 1, you build your AI dream team, the teacher ensemble. Step 2, you let that teacher make all its predictions, which basically creates the ultimate answer key. And then step 3, the small student model doesn't learn from all the messy raw data. No, it learns directly from the teacher's perfect answers. It literally learns to think like the genius teacher.
Now, this all sounds amazing in theory, right? But does it actually work in practice? Let's look at the data and see if this clever student can really match its brilliant teacher.
This is the million-dollar question, isn't it? Did all of this cleverness and all this hard work actually pay off in the end?
Okay, this chart tells the whole story, and it's just beautiful. On the left side, you've got performance, and in this case, a lower score is better. Across the bottom is the computer power required. That orange line way over to the right, that's our powerful teacher ensemble. Amazing performance, but computationally very, very expensive. Now, look at that green line. That's our distilled student. Its performance is nearly identical to the teacher, but it gets there with just a tiny fraction of the computing cost. And here you can see what that actually looks like in a real scenario. On the left, you've got a standard, single model. It makes a decent prediction, but it's not perfect. On the right, the ensemble makes a much more accurate forecast. The magic of distillation is that the student model learns to produce those high-quality predictions you see on the right. But with the speed and efficiency of the simple model on the left, it's the best of both worlds.
The numbers on this table really drive the point home. We're looking at accuracy here, which is measured by an error score, where a lower number is better. The standard single model sits at a 0.545 error score. The giant teacher ensemble, which costs 20 times the computing power, barely improves on that. But now, look at our distilled student. For only a tiny bit more compute costs than the baseline model, it achieves an error score that's virtually identical to the giant teacher. It's the teacher's brain in the student's lightweight body. So what's the bottom line here? You get the wisdom of a 20-model super brain for roughly the price of just a single one. That is a computational efficiency gain of over 20 times. It's an absolute game changer.
And this is where things get really exciting. Because this technique, this idea of distilling massive AI intelligence into a small, efficient package, well, it's not just for self-driving cars, not by a long shot.
This unlocks the possibility of putting truly powerful AI into all sorts of devices that have limited power and size. I mean, think about it. Smarter drones, more helpful smartphones, wearable health monitors that could make complex diagnoses on your wrist, or factory robots that can adapt to new situations on the fly. The key insight here is actually bigger than just making AI smaller. What we've really found is a way to democratize elite-level AI. We can now take the kind of intelligence that used to require a warehouse full of servers and literally distill it into a model that can run right here, in your hand, or on the move. And that leaves us with a pretty provocative final thought. For years, the most powerful AI has lived in the cloud, right? Accessible only through an internet connection. But this changes everything. So what happens to our world when every single device, no matter how small, has access to truly elite AI thinking, right on board?